Hello, everyone. Hope you're all doing well. So we are going to continue on with organics. One thing to note is next week is Thanksgiving week. We are meeting on Monday. We aren't meeting on Wednesday. Okay. So, so be prepared for some lecture on Monday. That'll just give us a little bit more room to lecture on some biochem stuff after a break. But then after break, it's going to go really, really fast. All right, we've got like 2.5, 3 weeks before finals. So most of you are doing pretty well. Hold on 1 sec, sorry. Will we have anything due this Sunday? I don't know. Let's look at the syllabus. Take a look. I don't have every syllabus for all of my classes completely memorized. You may think that that's all I do is sit around and no, just work on chemistry and teaching chemistry, but I don't. So let's remind ourselves together. We have this weekend's date is what, the 22nd? Yeah, you will have acids, bases, pH, and buffer. So you do have a lab due. And let's see what else. My guess is that the homework for acids and bases was last weekend. But yeah, so mastering chemistry, you may have, my guess is this organics is probably going to be due. You'll just have to check mastering chemistry. Mastering chem. Do we have mastering chem? Oh, let's just go look. Okay. We'll peek together, see what's happening. So yeah, you'll have chapter 11, which is all this fun organic stuff. And then because of Thanksgiving week, right, we will meet on this Monday. We won't meet on Wednesday, so you won't have anything for the 29th, but you will have it the following. So you'll get a day off there. All right, so organics. Super fun. I actually I kind of like organics. Open you up. So we had talked about the cycloalkanes. Some of the differences with the cycloalkanes. So cyclo meaning it's in a circle. So every carbon is attached to another carbon. We don't have any tails. It's an ANE ending, so it is all single bonded. But because every carbon is like a central carbon, each carbon is only attached to 2 hydrogens. So propane and cyclopropane will have a different number of hydrogens. These will have 2 less hydrogens because there is no end carbon. So if I was to draw, let's get out of here. Oh, you have your test. Almost forgot about that. You have your third test on Sunday because we pushed that back. Bah! So let's not forget that. Yeah, I had a feeling there was something else. I'm like, yeah, so make sure you get your test done as well. Okay. I'll remind you on Monday too. So let's see here. So if I have propane versus cyclopropane. Okay, the pro is letting me know that there's 3 carbons. The ane is letting me know they're all single. This is cyclo, this doesn't have the cyclo. So if it doesn't have the cyclo, we just assume it's a chain. C bonded to C, bonded to C. This is an end carbon, so it'll have 3 carbons bonded to a central carbon, which has 2, bonded to another end carbon. So the formula for this is going to be C3H, take this number, multiply it by 2 and add 2, so 8. Cyclopropane is different in that it's a CH2 bonded to a CH2 bonded to a CH2, and then it's bonded back to itself, right? So if each carbon is bonded to 2 other carbons, it only has room to shove 2 hydrogens in there. So in this case, carbon would be 3, but hydrogen would be 6. So your cyclo will always have 2 less hydrogens than your non-cyclo. Do we do this? These names? I don't think so. So go ahead and name these, okay? Using the IUPAC system. We did. Well, we'll do them again real quick. We did. Okay. Okay, well, let me just review them real fast. So this thing, count your ends and your corners to figure out how many carbons you have. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, so that would be oct. They're all single bonded. A double bond would have a second dash or stroke there. So this would be octane. It's not in a cyclical form, so just octane. This one, 1, 2, 3, 4, 5. So prop, they're all single bonded. Is it possible to move the mastering chemistry homework to be due on the 29th instead of the 20th? Yeah, I guess I can do that. Let's see. We'll do it right now, okay? Because I just had it open somewhere. There we go. We're going to move you, you cute little guy. We'll move you right there. Done. It's done. Okay, so cyclo, this is a cyclic structure, 5 carbons. So pent, all single bonded, pentane, so cyclopentane. Bam, done. Go ahead and name these structures. Okay, so first one here, we've got 1, 2, 3, 4 carbons. They're all single bonded. It's a saturated hydrocarbon. Hydrogens fill all the slots. So we would just call this 1, 2, 3, 4. 4 is going to be but and ane, butane. This one here, 1, 2, 3. It's in a cyclical structure. So it's going to be, excuse me, cyclo. And then if we have 3, that's cyclopropane, all single bonded. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, all single bonded, octane. 1, 2, 3, 4, 5, 6. 6 carbons, all single bonded in a cyclical shape. So we would call this cyclohexane. So now we're going to start to add substitutes or accessories. So look at these two structures here. They both contain 4 carbons, and they both have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, but they are not the same thing. Okay, this isn't just one where I've like kinked the line. This is actually a different structure. Here we've got a single chain here, or a one long single chain. Here I have a shorter chain with a branch or a little accessory arm. So this branch, we're gonna call a substituent, or it's like an accessory group. We have to denote that that is an accessory off of our chain. So we call these two things structural isomers, which means that they have the same molecular formula, but the way that the atoms are arranged are different. So both of these have a butane molecular formula, or C4H10, but one is a single straight chain. The other one is a smaller chain with a branch. So I want you to try and draw this thing in 3 different ways. Okay, something with 5 carbons and 12 hydrogens. Hint, one of them is a long chain of carbons. All right, then you've got to try and play around with the other 2. All righty, so one of these is going to be the chain. So CH3, CH2, 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 CH3. That's one structural isomer. Another one is if I shorten this chain up and I took this thing and stuck it on one of those inside guys. So CH3 to CH to CH2 to CH3, and I stuck one thing here, CH3. If this thing was instead on the top, that's okay. What if instead of putting it here, you put the accessory here? That's the same thing. It's just flipped around, right? So this is the same as this, CH3, CH2, CH, CH3, CH3. Okay, these two things are the same thing. I just happen to like flip it and then rotate it up. We need another one. The other thing I could do is I could technically take this thing, rip it off and stick it on here. So the last one would be CH3 bonded to a carbon, bonded to CH3, CH3, CH3. Notice how I changed the number of hydrogens on that central atom if it got an accessory, right? Do you see how this carbon here, it's bonded to one carbon there, and then it has an accessory. So how many open slots does it have for any hydrogens? It only has one. But the number of hydrogens still is 12, right? 3 here, 6, 9, 10, 11, 12. So it's still the same molecular formula. It's just structurally set up different. What did I do down here? My central carbon, because it has 4 groups off of it, there's no room for this central carbon to have any hydrogen. But these all have 3 hydrogens, which gives us the 12. One thing that is not a structural isomer, is to go like this. Okay, CH2, 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 CH3. And then you're like, well, I'm going to put it here, CH3. That isn't a structural isomer. This, what is this? This is the same thing as this. It's just kinked to the side. But remember, these are free to rotate around themselves. So I would call this thing and this thing the same. I would name those in the same way. So that would not be an isomer. It has to actually have the carbon atoms arranged in a new way. So there we go. There's our long chain. There's a shorter chain with a single branch. There's an even shorter chain with 2 branches on there. And each of those we will name differently, even though they're all pentanes or 5 carbons and 12 hydrogens, they have different names. So how do we name these? Substitutes are atoms or groups of atoms attached to the carbon chain and include an alkyl or a halo group. An alkyl group is a group of carbon atoms. You use the same IUPAC system name. So if it's 1 carbon, it's meth. If it's 2 carbons, it's eth. If it's 3 carbons, it's prop. But you add a YL to the end of it. So a methyl group, if I was to say, methyl, that means that it's 1 carbon, so like a CH3, and it's an accessory. It's not attached on the main chain or the longest chain. Ethyl would be a CH2 attached to a CH3. Again, this would be an accessory coming off of the main chain. We can also have halo substitutes. Halo for halogen. So this is where we add fluorine, chlorine, bromine, or iodine. And those names are going to be fluoro, chloro, bromo, or iodo. So sometimes a branch can have one of these little guys floating off of it. So let's go ahead and start naming some of these things. There's our cute little methyl. There's a longer ethyl. There's a propyl group. If you get to a situation, see how this propyl group is attached just on one side? If you happen to attach it in the middle, like this is known as isopropyl. So have you ever heard of like isopropyl alcohol? It's a branch where the secondary or the substitute is being connected by a central carbon as opposed to at the end. We're not going to do a whole lot with isopropyl. I don't think I even test you guys on it in the test, but you may see it pop up in the homework. Here is our halo accessories, so fluoro, chloro, bromo, and iodo. So when we're going to name an alkane group with these accessories or substitutes, the first thing you do is write the alkane name for the longest chain of carbon atoms. So find your longest possible chain, and that will be sort of the base name. Number the carbon atoms starting from the end nearest the substitute. So find where the replacement is or the arm accessory, and we'll start naming carbons off of, or numbering carbons off of that. Then you actually have to give the location of the substitute or the accessory, and you put it in alphabetical order as a prefix to the name of the main chain. It's always easier, I think, when we do an example. So let's do an example, okay? So this thing. Do you see how this is slightly different than what our original simple alkanes are? The difference being I've got here something that isn't a hydrogen, and then over here I have something that isn't a hydrogen. So the first step is to count up your longest chain of carbon. So 1, 2, 3, 4, 5 carbons. Now, on this second carbon here, we have a chlorine accessory. On this carbon, the third carbon here, we have a methyl accessory, or a single carbon with saturated hydrogen. So count up your carbons. We've got 5, so we'll go with pent. Are they single bonded to each other? They are, so we'll go with pentane. And I'm going to kind of write pentane a little bit. I'm not going to start it here. I'm going to write it over here so I have some space in front. So pentane. Now I need to number my carbons, and the way you number your carbons is so that your accessories have the lowest possible numbers. So it doesn't always start on the left. Sometimes it could start on the right. In this case, it's going to start on the left. I'm going to make this carbon 1, 2, 3, 4, and 5, because then that would put the chlorine on the 2 and the methyl on the 3. If I went in the other direction and said this was 1, 2, 3, 4, 5, the methyl would be on the 3 and the chlorine would be on the 4. Those are not, you want to go with whatever the lower numbers are. So I have a chloro group on my second carbon, and I have a methyl group on my third carbon. Well, what comes first in the alphabet? Chloro or methyl? Well, C comes before M, so we're going to list that first. And we have to say what carbon it's on. So I'm going to say 2-chloro. That lets me know that my chloro accessory is on the second. We've got a methyl group, and that's on the third. So then we're going to, come on. And just do what you're supposed to do. So then dash 3-methyl, and whatever the prefix or the accessory is that sits right before the long carbon, those just sort of get smooshed together. Okay, so we don't put a dash in between those. Dashes go between numbers and words. Commas go between numbers. And I'll show you that in a little bit. So 2-chloro, 3-methylpentane. There we go. All right, again, dashes between numbers and words. So this 3 has a dash on the front and on the end, and then smoosh this accessory up against your root. If you have a cycloalkane, so a circular thing, when there's only one substitute is attached to a cycloalkane like this, the name of the substituent, whatever your accessory is always in front of the cycloalkane name. You don't need a number. if it's a single alkyl group or a halogen. So like this, I don't need to put a number on this. I would just assume that this is carbon 1. Okay, and this is 2, 3, 4, 5, whatever. The accessory for the cyclo will always sit on carbon 1. If you only have one of them, I'll tell you if we have multiple ones what to do. So this thing would be called ethyl cyclohexane. There's 1, 2, 3, 4, 5, 6 carbons. They're in a cyclical structure. So that's the cyclohexane. And then what is our accessory? It is a carbon bonded to a carbon. So that's 2 carbons, that's ethyl. If we're doing haloalkanes, these are ones that have those halogens in them to replace one of their hydrogens, one of the carbon's hydrogens. You put the substituents in alphabetical order and then number them according to where they sit. So looking at this thing, this is methane, right? 1 carbon, and one of the hydrogens have been replaced with the chlorine. I would call this thing chloromethane. Why don't I need to specify that it's in carbon 1? Well, how many carbons are there? There's only 1 carbon, so you don't need to say 1 chloromethane. Its common name is methyl chloride. Common names you are not going to get tested on, okay? Because the only way you learn those is through just working with the materials. So, but the IUPAC name you do need to know. Looking at this one, I've got CH3 and CH2. This carbon here, one of his hydrogens has been replaced with a bromine. So we would call this bromoethane. Do I need to say that it's on carbon 1? No, because there's only 2 carbons. They're both terminal carbons. So whether it's on this one or it's this one, I would number it in such a way that it would be carbon 1 anyway. So you don't need to do that. But what happens when we have 3 or more carbons? 3 or more carbons, you need to specify where the accessory is. So in this one, I've got a chain of 3 carbons, that's propane. One of the end carbons has a fluorine attached to it. So I would number the carbons 1, 2, 3, and this would be 1. The fluorine is on the 1, so 1 fluoropropane. If I had something like 2 fluoropropane, that would mean the fluorine is sitting here. There would not be a 3 fluoropropane because 1, 2, 3, I would just count them in the other direction and it would end up being 1. Isn't this fun? Doesn't this make like inorganic nomenclature a piece of cake? So let's look at this guy here. So if we want to draw the structure of this thing, 1-chloro-2,3-dimethylheptane. The di here means 2, so it means that there's 2 methyl groups. You have to specify that. So if you have 2 methyl groups, you need to say di. If you have 3 methyl groups, you have to say tri. This is saying that there is a methyl group on the 2nd and the 3rd carbon, and that there's a chlorine group on the 1st carbon. Now, how long is the chain? It's a heptane, so it's a 7 carbon chain. So when I'm going from the name to the drawing, I make it easy on myself. And the first thing I do is write out the chain. So we're gonna have carbon, and don't put your hydrogens in yet, okay? So carbon bonded to carbon, bonded to carbon, bonded to carbon. 1, 2, 3, 4, 5, 6, and 1 more. Again, don't put your hydrogens in because we haven't added our accessories yet. Let's just make this carbon 1. You can decide which side you want carbon 1 to start, but I'm going to do it here. This says that there's a chlorine on carbon 1. So one of these, and you can put it facing up or you could put it facing down. It doesn't matter, but I'm going to put a chlorine there. Then I've got methane, and I've got specifically 2 methanes. There's one on carbon 2. So if this is carbon 1, this becomes carbon 2. So I'm going to put a methane, CH3. And then there's another one on the 3rd, CH3. Does it matter that I put them on top and bottom like this? No. Now at the very end, I'm going to saturate it with hydrogens. So anywhere that the carbon needs hydrogen, I'm going to fill that in. So this carbon has 2 buddies, right? So he only has 2 open slots, so I'm going to give him a 2. What about this one? This one has 1, 2, 3 buddies, so he can only get 1 hydrogen. This guy here also only has 1 open spot. This guy has 2 open spots, and then we just kind of, these are all like what we normally see. Okay, so this would be the structure for 1-chloro-2,3-dimethylheptane. Any questions on that outside of, we need to practice it? I think it's kind of easier to go from this way to this than to go from the structure back to the name, personally. All right. So let's do, I want you to try this out. Draw the condensed structural formula. That's where you like smush the hydrogens and the chlorines together. The hydrogens and the carbons together. So we've got 3-bromo, 1-chloro-butane. And if you have a bromine that points up or a chlorine that points down, and somebody else had their bromine pointing down and their chlorine pointing up, I would grade those the same because I can see it in 3 dimensions. So I know that they're all the same structure. So Jordan, if you are looking at 4-ethyl-2,2-dimethyl octane, what it means is that there's 2 methyl groups and they both are on carbon 2. So one would be pointing up and one would be pointing down. They're not chained together. If they were chained together, we would call it an ethyl group, but they're methyl.
Awesome, thank you. I was very confused by that.
Okay, yeah. All right, so we got butane. So you got to remember how many carbons there are in a butane. So carbon, 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 1, 2, 3, 4. We're going to say that this is 1, and there's chlorine on carbon 1. So give him a Cl. On the 3rd carbon, 1, 2, 3, we've got a bromine. So I'm going to put a Br. Then I'm going to saturate it up. This has room for 2 hydrogens. This also has room for 2 hydrogens. This only has room for 1 hydrogen. And this tal guy has room for 3 hydrogens. This is the same thing as if I drew it like this. Okay, these are the same thing. Whenever they're single bonded, they have the freedom to rotate, and then they can rotate obviously in the other way. Those are, that slide sucks. This needs to be moved over here, and this needs to be closer to here. I think there's some sort of formatting issue there. There we go. Yeah, we like that. A lot of times you'll see it drawn like this, skeletal structure. Notice though, when this is drawn, this is a carbon, this is a carbon, this is a carbon, this is a carbon. So 1, 2, 3, 4. This line is including the BR bond. Okay, so there's not a carbon sitting at the end here and then BR is attached to it. Same thing here, kind of looks like that there's 5 carbons here, but they're not. This line is encompassing the chlorine. So just make sure that you're not seeing this as 1, 2, 3, 4, 5 carbons. 4 carbons, and this is clumped together. All right, so let's go ahead and name these. I'm gonna give you, I want you to try. So name this one and name this one. These don't have all the carbons involved, so you kind of have to figure that out for yourself. All right, so when looking at this, I'm gonna name the thing by first finding the longest carbon chain. So 1, 2, 3, 4, 5. 5 carbons, pent. They're all single bonded, so I'll A and E them, pentane. I do have an accessory right here. So that's a chloro group. And if I counted this as 1, 1, 2, 3, 4, that would put chlorine on the 4. So instead, I'm going to count this as 1, 2, 3, 4, sorry, 5, because then it'll put it on the 2. We always want to go with the lower number. So it's not always going to be written conveniently like that. So chlorine is on the 2, so 2-chloropentane. What about this thing here? This thing I need to find my longest carbon chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is also a pentane. This thing has methyl accessories. Here's one methyl accessory. Here's another methyl accessory. I'm going to count this as carbon 1, this is 2, and this is 3. So this has 2 methyls, so we've got to go with dimethyl. And they are on the 2 and the 3. So 2, 3 dash dimethyl pentane. So 2-chloropentane and 2,3 dimethylpentane. so I'm going to give you some of these. Know that what you guys have seen thus far is the longest chain is like conveniently written as the horizontal. That's not always going to be the case. Sometimes you've got to do a little looking. So I want you to name this thing. Okay. Okay. So if you did this, 1, 2, 3, 4, 5, 6, 7. There's 7. So this is heptane. You are wrong. Why? Because that isn't the longest chain. It is conveniently written to appear to be the longest chain, but where is the actual longest chain? Instead of this being part of the main chain, this is going to be the main chain. This is going to become accessory. So the number of carbons is really 1, 2, 3, 4, 5, 6, 7, 8. So this is octane. You want that longest chain to eat up or take up as many carbons as you possibly can. So we're going to go with octane, all single bonded. Accessories. Here's one accessory. Here's another accessory and another accessory. So how do I want to count this? Well, if I go this way, it'll be 1, 2, it's on the third, 4, 5, 6, and 7. So it would be 1, 2, so it'd be 3, 6, 1, 2, 3, 4, 5. I swear I can add 5, 6. 3, 5, and 6 if I go in this direction. What if I go in the other direction? It'd be 1, 2, 3, 4, 5, 6, 7. So we can do 3, 4, and 7, or 3, 5, and 6. I'm going to go with 3, 4, and 7. Makes this closer to the end. So. All right, so now we have decided this is 1, 2, 3, 4, 5, 6. Sorry, this is on the 6th. 6, 7, 8, Okay, so this is on the 6th, yeah. So how we put these in front is based off of their alphabetical order. So bromine is the first, we've got bromo, chloro, and methyl. So 3-bromo dash 4-chloro dash 6-methyl octane. 3-bromo 4-chloro 6-methyl octane. Is that what you guys got? No. Okay. Let's do another one. How about that? No, because they're so fun. All right. CH3, CH2, C, BR, BR, what do I want to do here? Hold on, don't write it down yet. Give me a second. I'm trying to, I want to give you something juicy. No, this is a, not done yet. Add some more. Okay, I think I'm done. Okay, there you go. Let's see if I can clean it up at all. It's pretty good. I'll give you all about 4 minutes so you can get it written down and named. Okay, so looking at this one, you know, fool me once, shame on you, fool me twice, shame on me. So hopefully you were able to see the longest carbon chain, or at least try and find it. So if we went across like this, 1, 2, 3, 4, 5, 6. Okay, how about this way? 1, 2, 3, 4, 5. Definitely not long enough. 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the longest chain. So 9 is non. They're all single bonded, so non-ane. We good with that? Good with that. Okay, cool. Jordan's good with that. So longest chain here, and then we've got a mess of accessories. So I can just already see that if I put this as carbon 1, these will fall into place in lower numbers than if I started here. Here, our first accessory we bump in at carbon 4. Here it's carbon 1. So this is, or rather carbon 2. So this is 1, 2, 3, 4, 5, 6. Scratch that. 7, 8, 9. We've got some, what do we got? We got a chloro here. We got some bromos over here. I don't even have enough colors for everything. I've got a methyl here. And I've got an ethyl here. And I've got to put all those in to make sure that this behemoth of a molecule is represented properly. So as far as alphabetical order, the bromine comes first. How many bromines do I have in total? 3. So it's a tri-bromo. And it's specifically on the 5th and then on the 6th. I have to specify that there's 2 on the 5th. So I do need to say 5, 5, and then we put the comma 6, tribromo dash. We've got chlorine left, methyl, and ethyl. So the chloro will come next. So 2 dash chloro. I should have written smaller. Then we've got an ethyl. Come on, pen. Do your job. So we've got this ethyl and it's popped off the 6. So 6 dash ethyl, sorry. We're just gonna get rid of non-ane. We'll come back to that. What else do we have? So I've got this, check, check, got these. The last thing I have is a methyl on the 4th. So 4 dash methyl, non-ane. 5, 5, 6, tribromo, 2 chloral, 6 ethyl, 4 methyl nonane. That's a mouthful. But I wanted to give you something that sort of applied all of the things together in one. All right, so if you can do this, you should be good with alkanes. Any questions? No, you're experts. All experts. All right, let's talk about some of the properties. Can we do another one? Yes. I'm not going to do one quite as long though, okay? I'll do a few short ones. If I can get out of here. All right. because I'm lazy and I don't want to put all the carbons in right now. So you're going to get it that way. You get the additional challenge of that. Let's see, we can do. Too seal. Put some points here. Okay, so top one here, longest chain, 1, 2, 3, 4, 5, 6, 7. I am going to make this carbon 1, this carbon 2, 3, 4, 5, 6, 7, 7. Come on. So that's gonna take heptane, be heptane, and heptane, you kind of think of it as like elimination. Heptane takes all those into account. So what do we have left over? We got a chloro, and a methyl sitting over here. So my chlorine comes before methane in the alphabet. So we're gonna, and there's 2 of them. So it's gotta be dichloro, and they're both on the second. So it's 2,2-dichloro. 1 methyl on the 5th, so -5 methyl heptane. 2,2-dichloro-5 methyl heptane. That's where I can write. Two dash dichloro dash 5 dash methyl heptane. All right, this guy here, one longest chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a nonane again. 1, 2, 3, 4, 6, or 1, 2, 3, 4, 4. Yeah, so we're going to start this as carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. As far as accessories, I've got a, what do I got? I got a methyl here. I got a methyl here and a methyl here, and I've got a fluoro here. So just one fluoro, 1, 2, 3, 4. So nope, it's not on 1. We have 1. It is on the 4th. So 4 dash fluoro. That takes care of that. We've got 3 methyls. And the methyls are on 3, 6, and 6. And these are going to be tri-methyl. So 4 fluoro, 3, 6, 6 trimethyl nonane. There's like so much more to it than this too. So we haven't even gotten into double bonds. Then we get into like real accessories like alcohols and aldehydes and all that stuff. So we're going to spend the last couple minutes moving forward. Some properties of alkanes, just FYI, these are good things to know. Different uses of alkane compounds result in their physical properties, including what their solubility and density is. So solid alkanes, and one example of a solid alkane would be the waxy coating that they put over fruit to help preserve it. It helps retain moisture as well. So there's a purpose for that shiny, waxy stuff on it. As far as what we expect the phases to be, alkanes with 1 to 4 carbons are gases at room temperature. So methane, ethane, propane, and butane will be gas at room temperature and at 1 atm. If you ever had a propane tank and you shook it, right, that's because it's under pressure. It is at room temperature, but it's pressurized. Same thing with like a butane lighter. Alkanes with 5 to 8 carbons are highly volatile liquids. So highly volatile meaning that they, it's easy for them to be sort of evaporate, but they are a liquid. Those would include pentane, hexane, heptane, and octane. Octane is what they put in gasoline, which is super volatile, right? You can smell it. You're not actually smelling the gasoline, but they put something in there so that you can smell it. If you have a alkane that is 9 or more carbons, or really 9 to 17 carbons, these are going to be liquids, but they have a higher boiling point and are found in things like motor oil, mineral oil, kerosene, diesel, jet fuels. These tend to be a heavier, denser liquid because of the longer chain. And then any alkanes with 18 or more carbons will be solid at room temperature. So paraffins, petroleum jelly, Vaseline, those are all really long chained carbons. So now you should sort of be able to, like if I was to give you, a couple different materials, you could say, oh, that's got to be less than 4 carbons because, or 4 or less because it's in gaseous form. That's got to be more than 18 because it's in solid form. In general, alkanes are nonpolar. Remember, nonpolar meaning it's a really balanced structure. So because they're nonpolar, they're going to be insoluble in water, and they're also they have a lower density than water. They're flammable in air, and they're found a lot in crude oils. So over here we have a picture of a beautiful oil spill that is, you can see the oil isn't mixing with the surrounding water, and it will sit on top of the water. That's one thing that's kind of nice about the oil, is that it doesn't mix. So they can actually go in and try and clean this up using some sort of physical net or something like that. So there was a huge oil spill in 2010. These slides are so old. There's been so many oil spills since then. But this was a really big one in the Gulf of Mexico. And it was releasing 10 million liters of oil a day into the water. So there's mechanical, this is what they tend to use a lot, which is where they have like a big boom or something, and they will skim the oil off, collect it. They can use chemical things where they will put a material into the water and it will attract the oil or clump it together. This is a really cool one, actually, this microbiological. There are certain bacteria that actually like to eat oil. And so they'll throw the bacteria in there, they'll eat oil. Now the bacteria does produce a byproduct, but the byproduct is much less harmful than the original oil itself. Alkanes like to combust. So when we have alkanes have this sort of strong carbon-carbon bond, when it reacts with oxygen, it will always form, right, carbon dioxide and CO2. We've already gone over this. It will release a lot of energy when we break those carbon bonds. So here's methane. It's a natural gas used to cook foods on our cooktop and to heat our homes. The bigger the carbon chain, the more energy there is to release. So we don't run our cars off of methane because we don't get as much bang for our buck. We run off of octane, which has 8 carbons. Here's butane. Butane is more useful for something like a portable burner. Again, why would we use butane? Because we don't want to lug around a huge container of methane. There's 4 carbons here. It's going to produce more energy when we combust it. We've got propane, which has got 3 carbons. Where are we? Okay, well, I want you guys to do this. So write a balanced equation for the combustion of propane. This shouldn't be anything too new for you, but try that out. Okay, so propane is C3H8, and you would have to, at this point, I could say, hey, write the combustion reaction for propane and not give you this, and you would be able to know what propane is. Okay, so we're taking this and we're combining it with oxygen to Oh my goodness, I'm falling apart here. Okay, so we've got propane combining with oxygen to produce CO2 and H2O. We want to balance the carbons first, so put a 3 here. Then we want to balance the hydrogens, so there's 8 here, so we've got to put a 4 here, and then we refine it by just putting a 5 in front of the O2. So that's a good rule of thumb, balance the carbons, the hydrogens, and then the oxygens whenever you have combustion. Oh, and we didn't even get into double bonds or triple bonds. Awesome. And there's a whole different way to name these. Okay. It's not totally different, but it is a little different. Okay. We'll leave those for Monday. So I will see you all on Monday. Have a really good weekend. I think there was one, Whitney, you wanted to chat. So stay around if there's anyone else who needs anything from